Hi guys, welcome to the second week of Access Engineering. Thanks so much for watching the video. If you haven't watched the previous video, definitely please go and do that. We talked about the introduction to circuitry and basic parts. And today, this week, we're going to be talking about Arduino code and how to factor that into our circuits with our breadboards and LEDs. Our fellow TAs, Adi, Trishla, and Miles will be demonstrating that this week. So yeah, stay tuned.
Hey everyone, I just wanted to give a quick recap on what we learned from last week in Access Engineering. We first talked about why we study electrical engineering, and we saw that electrical engineering is a component in a lot of the everyday devices that we use. For instance, we could see electrical engineering in our computers, 3D printers, and bionic arms. Um, Electrical engineering is kind of like the component that combines the software and the hardware of the components we see in our everyday lives. We also discussed the design process needed in electrical engineering. We first have a diagram where we essentially design our circuit that we need to construct for our device. Then we look at our layout and see how each of these components are actually laid out on a PCB. Then we build our actual product and make sure that it's user friendly so anyone can use the electronic device. Finally, we discussed one of the most fundamental laws in electrical engineering, which is Ohm's law. Ohm's law says that the voltage is equal to the current times the resistance, and we saw how each of these components are related to the circuit and what each of these components do in the circuit. We also did a brief intro on an Arduino. An Arduino is like a mini computer that we can use to actually upload code and be able to build our very own circuits. We can use an Arduino, for instance, to essentially light an LED. And to light an LED, you would upload some code that would be able to control when you can light up the LED, and you would create this circuit on your Arduino in which you would use a resistor, an LED, and a few wires, and a battery.
Hi everyone, my name is Aditya. I'm one of the electrical engineering teachers, and today we'll be talking about using push buttons. If you guys have any question about this lab or any previous labs, please feel free to email us or bring any questions to the sessions we have on the weekend. Um, yeah, just try and get all your questions answered because when you actually do this experiment in real life or in the future in college, it'll be helpful for you to know everything that we talk about today. So I'll share my screen and I'll try to annotate stuff so it'll be easier. So yeah, welcome to Access Engineering, Electrical Engineering Week 2. Today's lab is to learn about, I'm not sure if you guys can see this, but today's goal is to design a simple circuit using push button, and push button is just this thing here. So the goal of this lab is to introduce the concept of breadboards and some of the components that you will see through the course. Pictured on the right is what you will be creating in Tinkercad and in person. It is a simple LED controlled directly from a push button. So there were a few key words here that we can, oh, never mind. Okay, that we can talk about. So the first thing is breadboards. You guys should have seen this in week 1. That's just this huge thing here, where you'll see on the sides this entire row is connected, electrically connected. This entire column is electrically connected, and in this midsection, each of the rows are electrically connected. So that's what a breadboard is. It's where you actually make your circuit. And you should be able to do this on Tinkercad fairly easily. You can find the Arduino Uno, each of these devices, each of these objects as well. If you guys have any questions about what these are, uh, okay. Sorry guys, I'm just trying to figure out the annotation stuff. Okay, so these are wires that you should be able to touch each of these buttons or these points to draw a electrically connected wire between them. This LED should also be available. This is a resistor, and this is the push button that's new for you guys this week. And if we see how this circuit is working, we'll see 5 volts. That's the power that's coming in. There's 5 volts coming. There's current flowing through this. That's your input power. So you have a current coming through this, and the current is connected on this side. We'll learn more about the button in the next slide. But what happens here is that when this button is not pressed, this isn't electrically connected, so no current flows. So basically, there's no current flowing there. But if this is pressed, then you will have current flowing through here. It'll go through the resistor, then it'll go through the LED like this, and then it'll exit through ground. And that's your completed circuit, which is very important. If you didn't have this ground connection at the end, there will be no electric current flowing, and hence your LED would not light up. You always need a complete circuit. Next. Yeah. Let me erase this part. Yeah, so the parts that you'll need, as I mentioned in the previous slide, would be the Arduino, cables, breadboard, red LED, jumper wires. Jumper wires are nothing but the little wires, the red and black wires we had in the previous slide, a push button and a resistor. All these parts should be easily available in Tinkercad, but if you can't find any of these for some reason, please email us. So now let's actually learn about the push button. So sorry guys. Okay, so the push button, how it works is you have two sides electrically internally connected already. So these two nodes basically are already connected, and these two are already connected. And once you press this button, then these two sections are connected, and then electricity can flow between them. So on the button, which is this, there are two sets of 2 pins that are always connected. However, when you press the button, all 4 terminals become connected. So this terminal are already connected. This terminal are already connected. When you press the button, then all 4 are connected. Cool. So in this picture, the groups in red are always connected. So these parts and then these two. And in the example from previous slides, the left 2 pins are always connected and the right 2 pins are always connected. When pressed, the left and right are connected, completing the circuit. So let's go to the previous slide here. So on this slide, these left 2 pins are always connected, and these right 2 pins are always connected. When you press the button, then you will have these 2 connecting, and then electricity can flow. So looking at this more carefully, we know that each of these rows are electrically connected, right? So when you have power on this node, or this entire row is 5 volts now. So you have 5 volts entering the current caused by the 5 volts entering the button, and these 2 nodes are electrically connected. And right now nothing is flowing through this, but once you join this button, these 2 are already electrically connected, so then electricity can flow here. As you can see, this button is connected here, so now you have current flowing through this row. Since there's a resistor, it goes through the resistor because there's no other path for it to follow. And once it's in this row, it can get in through this LED, come out from this end, and then this row is electrically connected, so it can get through this wire and go to ground. Cool. I hope that made sense. If not, again, you guys can email us, ask us any questions. We're always ready to help. And yeah, someone else should be continuing the presentation now. Thanks, guys.
Hi, everyone. My name is Miles, and today I'm going to be talking about an exciting electrical engineering tool that we use. And I'm also going to be showing you how to turn on an LED with a push button using no code. Okay, so this is the digital multimeter, and we use it to check things like voltage and current. Today, we're just going to focus on voltage. Voltage is just a potential difference between 2 points. So think of it like being 30 feet high. Okay, that's kind of confusing because 30 feet high from where, right? So we need a reference point. And just like in real life, every voltage measurement has a reference. In most cases, this is going to be ground, which we can denote as GND or 0 volts. So to test something, we take a black negative terminal and connect that to ground, and then we take a red positive to what we want to test. Okay, so this is a little schematic of turning on the LED using hardware. So you can see this example on the right, and looking at the diagram and thinking about what we've talked about on the previous slide with the red and black terminals being positive and ground, you can kind of trace through the circuit. So we start with a 5-volt wire, and that connects to the bottom right terminal of the push button, which is the black circular device to the right of that red LED. The bottom left terminal of this button is connected to the resistor. That's kind of that yellowy thing with the stripes. And that resistor connects to the right terminal on this LED. And because the right terminal is a little bit longer, that's going to have this curvy shape on the schematic. That's why it's bent like that. Okay, so you can see if you can trace the rest. Like the left terminal has that black wire going to ground, and then the ground goes to the Arduino. Okay, so now we're going to build this in person. So all these connections should be identical to what you just did in Tinkercad. And no code is necessary here because we're using the built-in hardware functions of the Arduino. A few side things: be careful not to connect ground to 5 volts or 3.3 volts of the Arduino directly because it could damage your board. And always use a resistor with an LED or you can damage the LED. Okay, so I'm going to build it now. So again, we need a breadboard. We need 4 wires. I'm using 2 reds and 2 black wires, and a resistor and a push button. So first, I'm going to build the board components, and then I'll connect the wires to the Arduino. So I'm going to take the push button and plug it in to the breadboard, kind of crossing this central channel. And you can see it's done the same on this picture. And then I'm going to take my LED and notice that, again, one of the prongs on the LED is longer than the other. So I'm going to take the longer one and plug it in kind of with the longer side towards the push button. Okay, so then I'm going to take the resistor and connect one side of it to the bottom left terminal of the push button, and then the other to the bottom, or just the right terminal of the LED, which is the longer one, if you remember. So it's a little tricky to do that. I use pliers. It makes it way easier. That's a good recommendation. I would do that. Okay, so now we have just kind of the board components. Now we need to use the wires. So I'm taking a black wire, connecting that to the left terminal of the LED, and then that other side of the wire is going to go to the negative on the board, which is ground. And then I'll take a red wire and connect one side of it to the bottom right terminal of the push button, and then the other side of it to the positive on the board. And then I'll take my Arduino in my final 2 wires, and I'll have a red wire going from the 5 volts on the Arduino to the positive on the board, and then a black wire from ground on the Arduino to the negative on the board. And then I'm going to plug it into my laptop and hope it doesn't blow up. Okay. Just kidding, that won't happen, so yeah. Wait, I'm bad at this. There we go, okay. Now if I push the button on the breadboard, the LED lights up. Essentially, I'm closing a circuit by pushing the button, and when I release the button, the LED turns off. It's hard to see, I apologize, but yeah. Okay, so the next slide kind of shows a clearer image of what you'll be creating. So again, you have your schematic on the left, and that's from Tinkercad, and then on the right is just an image of what yours may look like. So again, you have the red wire going to the bottom right terminal of the push button, and then on the bottom left terminal, you have a resistor going to the right terminal of the LED, and then the left terminal of the LED goes back to ground. Okay, and that's how to turn on the LED using just hardware. Now you're going to be doing the same, but with code.